Before we get too much farther into our exercise in learning machine learning with BigQuery, we're going to learn a little bit about some terms in machine learning. It's kind of important to just do some quick overview. We're going to get further into all of these as this class goes on, but for now we'll kind of do a quick crash course on some different aspects of the problem, as well as we'll get into how we actually clean data and how we transform some of this data so that we can use it effectively. So there are three major types of machine learning. In fact, if you had asked a couple of years ago, people probably would have told you that there are two major types of machine learning: supervised and unsupervised. There's also reinforcement learning. Supervised learning is what we're going to focus on for this example, and supervised learning is basically we have some data and we know what the answer to the question is with this data. So a good example of this, is there's a tutorial on BigQuery ML that uses penguin weights. So we have a bunch of recorded penguin data, and we have the weights of each one of these penguins. And if we have all of that, we can kind of say we know what the answer is if we're trying to predict the weight of penguins. Penguin weight is a known thing, and if we have enough of that, we can predict what penguin weight is for other penguins where we don't necessarily know the weight, but we know some of these other attributes for that data. Unsupervised learning is a little bit different. Unsupervised learning typically has to do with like categorizing or clustering our data, and really we don't know what the answer is. It's unsupervised learning. We're thinking more about how we group things or how they're similar, and that tends to be a different kind of problem because we don't actually know what we're trying to predict. We're trying to learn a little bit more about the problem area in that situation. And reinforcement learning is a different kind of thing entirely, because reinforcement learning is sort of like live learning. Like something is happening that is reinforcing certain behaviors. Reinforcement learning might be trying to train a model that can navigate a maze, and kind of giving different incentives, I guess, or like different I guess there's probably a term for this in reinforcement learning, but basically you're giving higher grades or higher motivations for certain behaviors. So reinforcement learning is this idea that you're sort of, you're learning what the right answers are as you move through a problem. So these are the three major kinds, but we're going to look at supervised learning. In fact, this is going to be a linear regression problem. So we're trying to take a bunch of different inputs to a problem, and we're trying to figure out how do we make a prediction, like how do we predict one value from all of that. When you're looking at a problem like this, I think it's really important to start with a few questions. The number one question is, what's the question you're trying to answer? Like, what are you trying to do with your data? Or what are you trying to do with your application? These are questions that are important to ask because you really want to know what you're trying to move to. Sometimes you have a bunch of data and you want to just use the data without really thinking about how you solve that problem. Because really the reality is that sometimes you don't have the right data. Sometimes you're not trying to ask the right question. Sometimes you're not trying to solve the right problem with the data that you do have. The other question is where you get the data, because there's a lot of data out there in the world, but when you're trying to make a prediction, do you have data that is well labeled is a really important question. You may have a lot of data. You may have very much data. You may have a very high volume, if we want to use one of those 5 Vs. But is the data well labeled? Is it accurate data? Like, is it easy to access? Is it easy for us to work with? Those are all important questions as well. So is the data any good? Like, is it the right kind of data, and is it usable data? Data that has a lot of noise in it, or a lot of inaccurate attributes, or maybe poorly recorded data, or data that's got a lot of missing data, that might not be your best choice. Now, it might be the best you have to work with. So is the data any good is really a good relative question to be asking. And then the big question, which a lot of people start projects for this particular purpose without thinking about whether or not machine learning is the right solution. Machine learning can do a lot of different things, but sometimes you don't need machine learning. Sometimes you need a couple of if-else statements, and that does it. Sometimes you don't need machine learning. You just need to calculate some averages and apply them. Like, it's not always the right solution. So this is something that we should be asking ourselves. Now, for this demonstration, machine learning is probably not the best possible thing that we could be using, for the simple demo that we're going to do. But is machine learning the right solution is something that you should be thinking about as you're exploring machine learning problems. We're going to look at features. So when we think about databases, we tend to think about fields or columns or attributes. We have a lot of different terms that we might use depending on the context of how we're looking at data. But a feature is a different kind of thing. When we think about data, we think about raw data. So, for example, you might have a date in your database, and that date may just be a long integer. It may be just be the milliseconds since January 1st, 1970. Like that's a pretty common way to represent a date, and that may be a complex type that has lots and lots and lots of properties. But ultimately, that's your data. That might not be the right feature for training a model. It might be more interesting to extract from that date whether or not it's a weekday or whether it's a Tuesday. It might be better to extract, is that a morning or is that an evening? So all of those can be different factors in how that date actually is useful. So that's kind of why we think about data is the raw information here, like the raw materials that we're using for machine learning. Features are more like the refined materials that we're going to use for machine learning. If you think about statistics, features are like explanatory variables. It's good when we're working with our data to use indicative features, but we might not know what those are yet. So we looked a little bit at the exploratory data analysis of some of this bike share data, and we might not know what we need from that yet. We might not know what's useful or interesting. So sometimes this process is very iterative, where we try to understand what data we have, we explore that data, we try to maybe engineer some features from that data, and then we try training some models, see how it goes, see what kind of predictions we get. And then we start over again. We go back to the data and we think, well, how can we re-engineer this? So this process can sometimes be very cyclical in trying to figure out how to build a model that's effective. Feature engineering is this process where we are looking at the data, identifying what's useful, evaluating it, and potentially transforming that raw data into something that we can use as an input to supervised learning, so that it kind of reduces the problem space in some ways to make, to like basically extract the important inputs. You don't always have to do this depending on what kind of models that you're training. You don't always have to do this based on the problem that you're looking at, but very frequently you're going to think about what are the inputs that I'm going to give to my model so that it can make these predictions. So this is a really rough overview. We're going to take a little bit of time in the next presentation looking into how we can engineer some features and what that looks like and why we might care about particular types of data. But for now, hopefully this gives you a quick overview of some of these terms, and we'll get a little bit further into BigQuery ML in the next video. Thank you for watching.